Hello everyone, welcome back to our channel. Today is my next start. Okay, after I think it's a quite good response of the biology ones. Okay, I saw a lot of friends. Okay, watch my whole video, so the watching time is quite good. So I'm more getting your encouragement. So I want to start the chemistry one. Okay, remember I will update biology every Sunday. So biology Sunday, so I think I will plan to update all chemistry every week on Thursday. So chemistry Thursday, okay. So first one I make it cute, okay, it's just like a gaming, okay. So in chemistry in the new 2025 syllabus, so IBDP is separating the two parts R and S, okay, and you will learn about S first, okay. You start from S1, S2, and S3, and each part divided into S1.1 or whatever, okay. The first one is very foundation. We call it particulate nature of matter. What does matter compose of? Okay? In the chemistry point of view, okay. Yeah, probably you have heard of it in integrated science or in the before science learning, okay. But now in IBDP, you need to load the definition rigorously. Sometimes they will give you marks, okay, when you say the definition clearly or when you can choose in multiple choice the exactly correct answer. Quite tricky, so we need to learn it clearly. So we are on the structure 1, okay? Model of the particulate nature of matter. And then 1.1 is about nature of matter, okay? Where does the particle come from? Where the matter come from? We call it constitution of matter. Constitution is the components of a matter, okay? So we have the concept, elements, compound, and mixture. You have heard of it, but now we need to give it a clear definition. And the definition will be released on next chapter. Elements, what is element? Your periodic table. Right? Elements are the primary constitution of matter, which cannot be chemically broken down into simpler substance. Okay, chemically broken down. It can be broken down by other way and becomes, you have heard, the electron, nucleus, proton, and neutron, right? But we cannot be broken down chemically. The elements, okay? So it's a difference. It can be broken down. We accept it, okay, but not chemically broken down, okay. So compounds consist of atoms, okay. What is a compound? It's atoms, these elements. What do? They join together chemically. They form chemical bonds, okay. They form chemical bonds in a fixed ratio and form a compound, not irregularly. There's some regularity, so the elements bond together by a fixed ratio. We call it a compound. And what's the opposite if this is a random thing? We call it a mixture. Mixture containing more than one element or compound, but in no fixed ratio. It can be random, it can have some flexibility, and they are also not chemically bonded. So two things difference between compound and mixture. Fixed ratio, compound. Chemically bonded, compound. The other, mixture, okay. And then we'll learn about what is a mixture later. A mixture, when two or more different compounds coexist, a mixture is formed. Remember, different, so they are not connected. If they are connected, we'll say one compound, okay? One component, okay? The component can be in different phases. For example, ice water, we call it ice water mixture. Yeah, of course, ice mixed with water, right? Then the ice is in the solid state and the water in the liquid state. So mixture can be in different stages. A liquid with a precipitate, or the precipitate in the solid state and the liquid is in the liquid state. Oh, sorry, I say too naive. So in a mixture, the component that we think their individual property. Ice is still the ice, water is still the water. When they mix as ice water, they don't change their properties. Okay, so it's a mixture. When two atoms join together form a compound, their property change. Okay. Compound's property and individual constitution, the atom elements are completely different. Okay. So separating molecules. So we have to think about how to separate them, or first of all, how to join them together. We call it a solvation. Okay. It's in the old time junior form we call it dissolve. Now we have back names. Okay. Solvation, making solvent. When a solid dissolves in the solvent, a solution is formed. You can say solvent plus solid becomes solution. Okay. And how can we take back the separate the molecule from a solution? First, we can use a filtration, okay? Filter out the particle, okay, from a solution, and the filtered liquid product we call it a filtrate, okay? The remaining clear one we call it a filtrate, okay? Or recrystallization, we can have a solution, we can form a solid in a crystal from the solution, okay? by putting a seed inside. Okay, we'll talk about it later. Recrystallization. Of course, we can use a evaporation. Okay, slowly remove the water out from a solution, and then the thing inside will remain. Okay, or I use a more vigorous way distillation to boil the liquid out with a lower boiling point, and the higher boiling point solid or high boiling point liquid will remain. Okay, or we just want to lower what is the composition inside a solution, we can use a paper chromatology, okay, separating molecules, but this time with different molecular mass. Okay, the heavier one will stop earlier, and the lighter one will stop later. We'll talk about all of them later in details. And next, we talk about a different kind of mixture. Wow, mixture have different kind. Yes, IBDP. We have a different concept of mixture. Homogeneous and heterogeneous is very important. Okay. After talking about this, ask yourself which one is solution. Okay. And then you know the difference. Okay. In the homogeneous mixture, remember this picture. Okay. Distribute uniformly. Right. The component distribute uniformly in the mixture. Okay. So every part of the mixture have the same combination or ratio of components. So every part of the mixture have the same property. Okay. For example, polar molecules form a homogeneous mixture with water because water is also polar. Right? They form polar bond. For example, alcohol is polar molecules, so alcohol and water can mix together. So they can mix a lot of fixed ratio. Right? Different ways also they can mix it with different ways also come out with concentrated alcohol or less concentrated alcohol, depends on how much water is inside, and we call it homogeneous. Okay, atom molecule. And then what is the other two? Okay, first, okay, what is a heterogeneous mixture? Heterogeneous mixture means that the component distribute non-uniformly in the mixture. Put some sugar in the solution. If the sugar is saturated, it will appears down, right? Or mixing oil and water, they separate because they have different property, different density, right? So the oil flows and the water sink. Okay, so component with different density form a heterogeneous mixture. Good example. They don't mix. Oil and water can't mix. Okay, and non-polar component, for example, oil or chalk or sand, form heterogeneous mixture with water. You can mix water with chalk and sand, but they becomes floating in the water, right? Then you can still see them, see the chalk, little chalk particle, little the sand particle, right? We call it precipitate. But the opposite, be careful. When all the components are concentrated as parts of the container, for example, the bottom, okay, it is not mixture. We call it a deposit. Okay? At that part of the container, meaning all the things deposit down. Okay, this is not a mixture. We call it a deposit. Okay, so remember homogeneous mixture, heterogeneous mixture filling all the container or the liquid. Okay, and the homogeneous uniformly, heterogeneous non-uniformly. You can see them clearly. Separate them. Okay, one layer and the other layer, or some precipitate inside. Okay, and the deposit is all in one part of the container, not the whole container. And we call it a kinetic molecular fluid. Don't be phobic about this big term. We talk about how change of state happen. Okay, we call it kinetic molecular fluid. It's a big name, but the concept you learn it already. We call it change of state. Okay, so the kinetic molecular theory is a model to explain physical property of matters, solid, liquid, and gases, and how they change with each other. And we know we have three stages of matter: solid, S, liquid, L, and gas. Of course, we know the fourth state, right? Plasma. Okay, completely ionized. A lot of electron, high energy electron, and the nucleus unknown. We call it plasma state. So we learn it solid, liquid, and gas. Okay, solid, we have the symbol bracket S, liquid bracket L, and gas bracket G. Okay, what is a dissolved in a solution? We call it an aqueous state. Bracket AQ. Okay, all are lower letter. But be careful about the L. Remember, write in the cursive way I recommend. That's people will think that you're writing one, right? Be careful, don't just write a straight line vertically down, right? So, so what is dissolve? Okay, dissolve is forming a homogeneous mixture, right? Change of state is a physical change. The chemical formula does not change. For example, ice become liquid, liquid becomes gas. Okay, solid, liquid, and gas, but still H2O, 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 right? No change of the chemical formula because chemically they are not changed. It's a physical change. Okay. Okay, for example, this type when you learn it already, but now we have different term, maybe solid liquid melting, liquid gas vaporization, gas condensation, liquid freezing. You learn it already, but yeah, we have the two special example: sublimation, solid directly to gas. For example, solid carbon dioxide in the air becomes as a gas carbon dioxide directly, okay, and at that position the gas becomes a solid quickly directly. And you know that from labs to right, solid to liquid separate more, liquid to gas separate more. So the potential energy increases, and we call it the energy of the matter increases because the enthalpy increases. Okay, we will learn enthalpy concept quickly, and then you will distinguish with the heat capacities, specifically that you have learned from physics. Okay, so melting, we want to write down chemical equation very easy. An arrow showing a before and after. Okay, the thing on the left of the arrow is before, the thing at the right of the arrow is after. Okay, so solid becomes liquid, we call it melting. So A bracket S arrow, A bracket L. Okay, so you can write down all the six things. Okay, I recommend you get a paper out. Okay, look at this one and then try to write down all these six processes. Okay, and you get familiarized with this bracket stay way of writing. You need to learn it. Okay, we always need when you write a chemical equation with this bracket or stay. Sometimes it's aqueous. Okay. Evaporation and boiling, well, they are example of vaporization. We call them all the things are vaporization, liquid to gas. Okay, so evaporation and boiling becomes examples of vaporization. They are also vaporization. Okay? And last one, we have the concept. We call it different temperature scales. Okay, in kinetic theory, we use a Kelvin scale. You have heard of it, absolute zero, right? 0 K, right? So in a kinetic molecular theory, there's a minimum temperature because it's 0 K. We can't be lower than that. At that point, everything stop moving. Everything stop moving. The average kinetic energy at 0 K is 0 for every molecule. So the K is defined very easily by degrees Celsius plus 273. So now it's a 27 degrees Celsius, right? So it is 300 Kelvin. We always remember Kelvin is larger. Larger by how much? 273. And we use the Kelvin scale. It is excellent because no negative energy. So we can use this Kelvin scale to measure the average kinetic energy of particle. Remember, it's average kinetic energy. Remember, it's a particle's energy. Which means that it is the motion of the particle that we can't see. We can't see. So change of temperature in degrees Celsius and Kelvin are the same because 1 to 1, right? Not the Fahrenheit. Fahrenheit has a ratio here, right? So change of temperature in Kelvin and temperature in degrees Celsius is the same. Remember, when we talk about change of temperature, you can say change of temperature is 10 K or 10 degrees Celsius. The same. Not applied to Fahrenheit, but we don't need to learn Fahrenheit. Okay? Science use Kelvin and degrees Celsius more, and actually we use Kelvin more in chemistry. Okay? So that's it. So you find it. Okay, chemistry is easy, right? Everything you learn in junior form, you just now to make it a more rigorous definition, and sometimes new concept, homologous mixture. Mixture has two mixture, okay, and something is not a mixture, we call it deposit, right? So we just can learn it bit by bit. Okay, following us. Okay, I planned to do about 100 videos, and you'll learn the whole IBDP curriculum. Okay, so today is a good start. Okay, you find it easy? Yes, excellent, because you are genius. Okay, you know science very well. So now it's start to make it more specialized in chemistry. Okay. See you next Thursday for another video. Bye.